So the next talk is from Christoph Petrausch. He had the task to renumber, to redo the whole network without renumbering all the servers. They went from a big layer 2 broadcast domain to a fully routed data center setup without touching the servers. So that's going to be interesting. Please welcome Christoph.
So yeah, we had the task to go from the single broadcast domain in each data center to a fully routed network. We did touch the server, but we did not touch the IP addresses because they're all over the place. Network ACLs in the software. Some software uses IP addresses for identity. So renumbering the host to do this migration would be a huge pain with a lot of stakeholders and a lot of discussions and a lot of steps. So we tried to make it without renumbering. So we started with this. So some of our data centers looked like this, a single big broadcast domain, because the network grows with the company and was set up when we had 0 network engineer or infrastructure engineers. And with all those things you do, they stick pretty long, and you grow and grow and grow and put it in, and it just works. And at some point, we had a lot of problems with the setup. We had a mix of switch vendors, so we had to buy a lot of hardware during COVID, and we just bought what was at hand and fit it because we had to grow. This was historically the network growing and growing. So what we observed is we had random breakdowns of the layer 2 domain, because nobody knows. At some point, some switch decided to not switch anymore. And often in the post-mortem, you can read like, okay, we started to bring down that link, and that link, and that link, and then it works somehow. Or shut down that switch, rebooted that switch. And it was, from an operational perspective, very hard. Nobody wanted to do real on-call because you basically was switching down things. Together with the historic growth, our documentation did not grow. There was a lot of, because it's layer 2, you don't need to collect which server is connected to which switch, because it will just do DHCP to get an IP address, and the layer 2 MAC out learning will do this thing, and if it pings, it's okay. We don't need any cable documentation. So during incidents, we had also a lot of issues like, okay, can we disconnect that switch without, what is affected if we reboot that switch, because nobody knows exactly what was on a certain switch. Also, we had a single layer 2 cross-domain across 2 data centers because we outgrow the co-location space. And we had to grow, so our co-location vendor just bought some co-location somewhere else in another data center, and we bought some hardware there. And we don't have any method to drain a link. It was just, okay, plug it up and hope that nothing breaks. In the new network, we had the chance to build it completely new. We built it with the fabric v6 only, so that every router in the new network fabric, so we only have routers there, and the biggest layer 2 domain has 2 nodes, so no big broadcast domain anymore. We go to the complete reverse, and all the traffic between the routers and the network fabric is IPv6, so there's every time an IPv6 next hop, also for IPv4 traffic, even if the hosts are still IPv4, but in the new network it's IPv6 first, and IPv4 is something we make work for those hosts are still there. Also, while we build up this new network with everything routed, we also build up a WAN. And the nice benefit of this is that we don't need 2 operational modes for our network engineers. So the networks in the WAN and in the LAN works exactly the same. There's the same technology. There's BGP for the routes. And what you see now, the hosts have same IPs, but with /32. how do we do all this? So as told before, in the old network, a big problem was missing documentation. It worked with layer 2, so nobody cared, but you don't have to do it to make it work. And in the new network, we want to make it so that without proper documentation, it does not work, because if it does not work, people will fix the documentation. And so we go with, okay, everything must be a netbox, every link must be a network, every IP address must be a netbox assigned to the interfaces. And we built some custom config generation with netbox as the source of truth, and added 2 services. We have called net topology service. This fetches data from the netbox database and presents it as a data model of our network topology. It's written, so the network topology is a big protobuf file where all hosts are in, all links, all interfaces, and it also does something which you cannot model that good in netbox, like, okay, you have 2 interfaces physically interconnected and they are part of a bond or link aggregation, and then the 2 logical interfaces on top are connected. You cannot model that in netbox, but in our net topology, those things are created. Also, we had all the traces between patch panels and stuff, and the net topology basically builds a logical view. Okay, that interface is connected to that one with all the intermediate patch panels stripped out. Yes, and this also makes us in the future proof for migrating netbox to a different source of truth, or updating netbox and having our network configuration model stable. On top of that, we have net configuration, net configurator it's called. And this is basically generating an abstract network configuration, which is independent of the vendor. So if you're remembering like lessons from your compiler, in studies, if you study compiler building, this is basically our abstract syntax tree of our configuration. So it's vendor neutral, it's a protobuf itself. And this is, in the net configurator, we only have role-based config roles where we say, okay, if your device is a spine router and it's connected to a leaf router, then the BGP session must be like this on that interface. And this is configured in the net configurator and based on the net topology. And then we have vendor-specific translators translating this abstract configuration into the configuration of the vendor. We have currently a Linux translator for all our network servers, a Junos translator because that's the current network vendor for our new network, and currently also for some we have, so in theory we can have more vendors, and we also have for the out-of-band access things, we also have a translator. And in theory, if you ever onboard a new vendor, we just have to write this translator and onboard that vendor into our automation. With Junos, the net configuration is quite simple because it is a big single configuration file you have to do on the machine, load it, and then you're done. We had the opportunity to migrate 500 hosts in the Big Bang move because, as told before, we had one layer 2 domain split across data centers, and that data center we needed to evacuate because the contract was cancelled, and so we have to move out there into the other data center, and our co-location provider there built a new data hall. So we had this chance to do it in a Big Bang move. Why Big Bang move? The new data hall was finished 14 days before we have to evacuate the other data hall. So we have 14 days to move over that 10 kilometers. Actually, we planned for 1 week for the completion of the physical move because it was told us in advance, okay, you have 14 days, and that's what the information 6 months before the move, and therefore we gave ourselves a margin of 1 week, then it must be done. We had some high priority servers, and they must be moved within 8 hours, and this was 30 to 40 servers we have to move within the 8 hours. What we also did when we migrate to the new network, beforehand we had a lot of 1 gigabit Ethernet, 10 gigabit Ethernet, and now we moved everything to 25 gigabit Ethernet, and all got the same NIC. And all those 500 servers need this new NIC. This was actually physically also quite challenging task for the network, for the data center operations guys. So every of those 500 servers unmount, mount the new NIC, ship them over, connect them to the new network, done. On this new NIC, there was also a challenge. We had, like, in the past, we used MAC addresses for IP address assignment. If you now onboard 500 new NICs with 2 ports, like 1,000 MAC addresses in a hurry, there's a lot of margin for error. Someone moved in the wrong line in the Excel sheet, and then everything is fucked. So also beforehand, we only had a single-digit number of servers at the new locations to validate the architecture, because time. Also, when we moved all those 500 servers, there will be a roughly equal and a little bit higher number of servers in the old layer 2 domain. They're still there, and they still need to interact with another. And what makes it a bit harder, until now we didn't have a unified network configuration stack. Some hosts were managed via our configuration management, some were only, the network was configured only at boot time once and never touched for years. This made it quite hard. So for the, as I mentioned, we had the problem with all those MAC addresses. And we just stripped MAC addresses from our architecture, because this is how the new network looks like from the perspective of a host. So we have a host in the bottom, and it has 2 physical connections to 2 top-of-the-rack switches, it's here called, but basically they are routers. And on this physical link, we choose a /30 prefix. This is a lot of IP addresses. A lot will ask, hey, why didn't you choose a /31? On this link, also the PXE boot, IPXE boot must happen. And in the previous job, we had problems with that using /31 IP addresses. So we had plenty of IPs left, and therefore we go with a /30, because we didn't have the time to debug, investigate, and thorough to make it sure that's worked on a /31, so /30. And for IPv6, we didn't choose a /127, because we later want to do our provisioning via IPv6 only, and we figured out, like, oh, okay, with /160, /127, there is no stateless auto configuration. So we choose the /64 here as well to be a future-proof there. What you see now on the physical interface, we have those IP addresses. They are assigned currently via DHCP on boot up, and there's this host IP on the loopback interface. This is the old IP from the old network. And in the future, when the host is migrated to the new network, this IP will be announced via BERT to the top of the rack routers. And so we now have the feature that we can just, a physical link can be broken and we switch over via BGP. In the past, we used a lot of MC-lag, which caused problems for this. Now you ask, okay, the new hosts have this /32 network, and a lot of hosts are still in the old broadcast domain. How to solve this? And for this, we used restricted proxy ARP. So one of our new routers will now, as soon as somebody ARP, so they're connected to the old and the new network, and as soon as somebody on the old network ARPs for an IP address and say, hey, who has the MAC address for this IP address, our routers stand in if they have a route, a /32 route for this IP address, but only then. We plan to do this with the QFX, with our QFX 5220, for which are our spine routers. During the 8 hours, we figured out they can't, or they do proxy ARP for all IP addresses. So the restricted proxy ARP was broken, and we moved within that 8 hours to our MX, which is our data center routers for the WAN, and they botched it together, and this works on Juniper, that network until now. For the nodes, we have seen we have a bird to reconfigure, we have a lot of IP addresses, and therefore we build an automatic reconfiguration tool onto the host. We call it NetDeeply. And the idea was, okay, we install it on every host before the physical move. And because I said, okay, until then we didn't have enough data to generate configuration in a good frame, this NetDeeply was deactivated until connected to the new network. So like a good Trojan, it sits there, was deactivated, and does nothing with the network configuration. And as soon as the hosts are connected to the new network, it takes over network configuration, throws away all the old network configuration be done. And we made it so the signals we used for being activated or deactivated is if the proper NIC online has a link and does a /30 prefix exists on the network interface. And this turns out to be quite robust. And so we never had a case where this NetDeeply took over and the wrong thing or did not take over when it should. And hopefully in the future we can just strip out the detection code because everything is migrated. So now we had done this big migration move. During the migration, we finished it, and within the 1 week, we were even faster. At the peak time, we migrated 200 hosts into the network in 1 day. But we had physical crews working around the hours to bring in the NIC, wire them up, and connect them. But for us, of the network team, we didn't have to do anything on the servers. The NetDeeply was installed. They put in the wires, boot up the server, everything configured and done. So now we had the problem, okay, we still have a couple thousand hosts in the old network. We don't have the opportunity to do this big bang move again. And we have to talk to many stakeholders now. Also, because we knew this new network is coming, a lot of hosts bought already had that NIC. And also we had other hardware-related maintenance ongoing where whenever a server was shut down, one NIC was grabbed and put into that server and booted up again. So in the worst case, if we now continue to migrate servers, we had to do up to 2 downtimes, one to mount the new NIC. And we also had the problem that due to logistics, sometimes the switches for the new network were not in place. So it could be that a host must be taken down for 2 times, one to mount the NIC and one to migrate it to the old network. And since many of the hosts already have the new NIC, we thought about, okay, how can we get rid of this second downtime or maintenance window? Can we do it live? And we also, as I told you, we already have this NetDeeply daemon running on every system. And we thought, okay, well, we just have to drain the old bond interface. So every host in the other networks has a bond interface for redundancy. And so we just have to drain the bond 0 outgoing. And the idea was, okay, wait until the BGP sessions to the new network is established and default routes are received. If that's the case, remove all routes pointing out the old bond 0 interface. So in that case, this can be done on Linux Live. We didn't drop any outgoing packets because we just removed the routes via the bond 0 and get a default route from the leaf routers, then outgoing traffic goes via the new network. What's missing was drain the bond 0 incoming, because this was a bit harder because we cannot signal in layer 2 like, okay, don't reach me anymore via that interface. We did a similar approach. The NetDeeply waits until the BGP sessions are established and some time for propagation, and then we just stop replying for up. So whenever the bond 0 interface gets the up IP address for the old IP, we just don't reply. We still have the IP address on the interface, so whenever some ARP table on all the devices in the layer 2 domain still have the old MAC addresses, we accept the traffic and go in, but we don't do any ARP anymore. And to make this a bit faster, we implemented proxy ARP on the routers. So whenever we have implemented proxy ARP, but we also do a gratuitous ARP. So whenever we receive this /30 route on a router, for like 6 times every minute, we just send a gratuitous ARP for that host IP. And this, in our experience, invalidated all MAC tables in the layer 2 domain, and so we could just drain the bond 0 live without dropping any packets. Also, this was then done by the data center people basically without us doing anything. It was all done automatically. Process-wise, we even did it like, okay, we let them cable all hosts and let them plug in the transceivers the wrong way, so they don't get connection, but the wiring is already there. And we then just went over without, or we notified our stakeholders, okay, this now is a switch over done, but you don't have to drain your machines, and they just go in, and the remote hands flipped the transceivers, plugged them in, and yeah, we had a rate of like 200 hosts per day, migrated like that. So all the wiring was done beforehand, but on the move day, it's like just plugging machines and wait. Oh, wrong button. On some of the data centers, we already had Sonic routers to separate some broadcast domains. So we learned, and this was not all one big layer 2 broadcast domain. In one data center, we had smaller layer 2 broadcast domains. And Sonic can't do this restricted proxy ARP, and therefore we wrote a restricted proxy ARP daemon in Go, and you can define it there. And while doing that, we run into a problem because our Sonic routers do MCLUG for redundancy. And if one of the Sonic routers do a gratuitous ARP with the virtual MAC address used for this proxy ARP, the other one received it and inject this via MCLUG in the forwarding table of the other one, and you basically create a black hole by that. So our gratuitous proxy ARP we have internally, I think the open source one does not have it yet, will also, whenever it receives the /32 route, will flush that MAC address from the neighbors table. What's also, even if the Sonic router has a /32 route, but a MAC table entry, the MAC table entry wins. I think this is because the MAC table is pushed down to the ASIC. We didn't debug why it was, but this is some behavior we observed. So what is the future? In the future, we want to migrate with baseline, migrate all hosts to IPv6 only, but this is a future project. And also, as we now have this daemon in place, which already configured the network, the next thing will be host-based firewalling based on roles in netbox. So you just have a filtering policy where you say, okay, when you have that role in netbox, so remove or source and destination have those roles in netbox, they can communicate on that port, and we will then on the fly generate NF table rules based on that with the existing network automation stack. Yeah. Any questions left?
Thank you, Christoph, for your talk. I'm pretty sure we will have questions. We have one from the internet.
Why do you choose to do BGP on the host itself? Wouldn't it be easier to use standard gateway on the host and handle the BGP, the top of the rack router?
We choose this on the host because we also have a lot of workload using Anycast anyway. So this also makes it. So we had already on many hosts BGP running. This made it a little bit easier, and also we have now the same operational manuals for draining a router link to a host in the network, draining a link to any of our transit providers, draining any link in the network is exactly the same operational procedure.
Hi. This is Malte. I'm a private individual, as always. I understand you're using no virtualization layer whatsoever on the hosts, right?
We use Kubernetes on that, but this is an overlay network. So we established the connectivity for the applications on top of that.
All right, thank you.
But in the future, we will, for example,
QMySol MPI-env. If you're doing BGP on the nodes themselves and they're running Kubernetes, have you considered just announcing the addresses you need for the Kubernetes workloads over BGP instead of doing an overlay network? And what came of that?
This is on our to-do list for will be coming. And we plan that because currently we have a lot of IP space left to have the pod IPs being routable. So I think previously I did a lot of Kubernetes things, and a lot of organizations don't have enough IP addresses to do that, but we luckily have.
Do we have any more questions? Doesn't look like it. So thank you, Christoph. Thanks for your talks.